In this lecture, we study the rectifier. Now, rectifier is an electronic circuit which will convert the AC current to the DC current. Here I have shown the pure DC, but rectifier circuit will use the pulsated DC. So here pulsated DC means what? It consists of AC plus DC. Now here some AC component is present. To remove this AC component, we use the filters. Thereby we get the constant DC. Now that we are going to study here. And rectifiers are different types of rectifiers are there. One is a half wave rectifier and another one is a full wave rectifier. So for the given input, if only half, for positive half cycle, we are getting the half, and for negative, no signal is getting, then this is called the half wave rectifier. Full wave rectifier means for both, for positive input, we are getting the positive half cycle. For negative also, we get the positive half cycle. This is called the full wave rectifier. Again, full wave rectifiers are divided into two types. One is a center tap full wave rectifier and another one is a bridge rectifier. Now, in this session, we will study the half wave rectifier. Now, this is a circuit diagram given and AC input 230 volts, 50 hertz is connected to the naturally generated signals or AC signals. That is 230 volts, 50 hertz sine wave. So here AC signal is connected to the, this is a step down transformer. Why we use step down transformer? All electronic devices now like your cell phone, laptop, everything, we are charging at below 15 volts or 20 volts. We use less voltage. So for that, we need to reduce the 230 volts to some less voltage. So for that, we are using the step down transformer. Now this step down transformer, this is the primary side and this is the secondary side. Secondary side, we get the sine wave with a reduced amplitude. So this is applied to the, now here the secondary is connected to the diode and this is the anode and this is the cathode. Again, cathode is connected to the load one end and load another end goes to the transformer. This is the construction of half wave rectifier. Now coming to the working, when the signal is applied to the diode, first positive half cycle appears across at the diode anode. With that, diode is a forward bias and it acts like a closed switch and current flows in this loop. When the current is flowing in this loop across the resistor, we get the voltage, that is DC voltage here, VM. This is a half signal we get at the output. So this is for the positive. After completing the positive half cycle, again immediately negative half cycle appears at the diode anode. So with that negative half cycle, now negative half cycle is at the diode. So negative is applied to the positive material of the diode, so to the anode. So with that what? It is for reverse biased and it acts like an open switch and no current flows in this loop. So thereby what? If no current is flowing means across the resistor what we get? We get the zero voltage. For positive half cycle, we are getting the positive half cycle at the across the resistor. And for the negative half cycle, because diode is acting like a reverse, acting like an open switch and no current is flowing, thereby we don't get any signal. And this repeats for the next signal also. So for the next half cycle, again we get the half cycle and for next negative half cycle, we don't get any signal. This repeats. So this is the working of the half wave rectifier. Now, transformer is not essential for the half wave rectifier. Whenever we need the low voltage at the output, we need this transformer. Otherwise, this AC signal also directly you can connect to the diode. It will rectify this 230 volts directly and give the output. But at the time here, the voltage is VM means what? 230 into root. So this is the voltage we get at the output. So if we want a low voltage at the output, we need to use the step down transformer. Now here we do the analysis for this waveform. We need to calculate the RMS and average values. Those values we require to calculate few parameters. So now here we are not getting the pure DC value. We are getting the pulsated DC, means what? AC component is present. So how much AC component is present that we need to calculate. And how much this half wave rectifier is converting this AC to DC, that also we need to calculate. So to calculate these parameters, we need the RMS and average values of these signals. Now for that, we will calculate the RMS value and average value for the sine waveform. Now here VRMS is equal to, now for this complete sine wave, the function, so V of t is equal to Vm sine omega t. Now here we are in the, on the x-axis omega t is there. So Vm sine omega t. Vm is the maximum voltage. For this entire sine wave, this is the function. And what is the time period for this function? 0 to 2 pi is the time period. Now for this function, we need to calculate the RMS, root mean square. The approach is from the last to first. If you take, then it will be very easy to calculate. So first we have to do the square to this function. Now take the function Vm sine omega t whole square. Now the square is done. Now after that, what mean? Take the mean. How to take the mean? Adding all the values and dividing with the number. But this is a continuous waveform, so we can't add a number. So we have to take the integration. That is, what is the time period? 0 to 2 pi is the time period. And what need to divide with the value, right? Here the time, we need to divide with the time period. For this, the total time period is what? It is 0 to pi is the time period, and we need to divide with the 2 pi. And the last one is what? Root. Take the root for this function and integrate with respect to omega t. Then you will get Vm by root 2. Now similarly, we need to calculate the VDC or V average for this waveform. Now if you see VDC or average, so how many number of positive values are there? Those many number of negative values are there. Now, if you take the average, you will get the 0 that we try to get theoretically. Now, what is the function for this waveform? It is a Vm sine omega t. Now, for this, if you take the average Vm sine omega t 0 to 2 pi 1 divided by 2 pi, if, and with respect to integrating with respect to d omega t. If you calculate this, then we get the 0. So this you elaborate and calculate the value, and this is a 0 for the VDC. Now, if you see here, this is a pure sine wave. There is no DC component in this waveform. What is DC? DC is nothing but what? With reference to 0, current should flow either in the upward or in the downward. It should not cross the 0 signal. Now, here if you see, it is going up, crossing 0 and coming down. So this is called this AC. Now, if you see here, the current is flowing only in the upper direction. With reference line, current is only in the upward, but not again in the straight form. So that's why some DC AC component is also present, but this is not a pure AC signal and this is not a pure DC. So this is a pulsated DC we call. So this is about the, now for this half wave also, we need to calculate the RMS and average. Now, for this also, waveform is V of t is equal to, V of t is equal to Vm sine omega t. Now, for this, if I calculate the VRMS, so what is the time period for this function? This time period is 2 pi only. After that, if you go and apply the waveform, again, this waveform repeats. Now, such waveform is repeating after the 2 pi. That's why 0 to 2 pi is considered as a time period for this half wave rectifier. Now, if I'm taking the root mean square, so first take the square of this function Vm sine omega t whole square, and time period is 0 to pi. Why? Because pi to 2 pi signal is absent. We have to take 0 to pi and divide with a 2 pi. Time period is 2 pi. And integrating with the d omega t and take root for this function, then you will get a VRMS is Vm by 2. Similarly, VDC is equal to V average is equal to, now here V average, we have to, values we have to calculate from 0 to 2 pi, but only signal is available up to 0 to pi. So that's why take the integration 0 to pi Vm sine omega t with respect to d omega t and divide this value with the 2 Vm, and that pi to 2 pi, no signal is available. So we have to take only Vm sine omega t d omega t. Now, if you calculate this one, you will get a Vm by pi. Now, this is the analysis for the RMS and average values for the half wave rectifier. So, in the next class, we will study the parameters.